There's the stop sign, so it must be recording now. Okay, now we will have a record after this. Okay, let's start off before I jump in. Do you have any questions on the material? On the submission stuff, anything to cover? Yeah.
I was kind of confused. When we submit our script, we'll get a bunch of different files out of it.
Yeah.
And then are we supposed to have another script that does the commands that check like how many of this thing is there? Like, do we need two different scripts to do that?
No.
So you can do it all in one.
So you're talking about to
Like you do all the things and you get the text files. And
Yeah.
then you need to go back and check them. Can you do that all in one and get the output?
Yeah, I mean you could, but the way I was thinking of it, you don't really need to. I mean, it was just little things like word count -L, right, to get the number of lines in the result, and that's just a way to check if you got the right result without having to print however many lines come out of it there. So you can just do that interactively. Yeah.
Oh yeah, so like in Word, you said write like one sentence for the answer. So
Uh-huh.
I guess like write like 1,000 characters.
Yep. Yep. So one sentence answers for the first part. It's just pretty basic types of questions. You can't really elaborate that much on how many lines are in a file or in a result. Like there's this many lines. Other questions? Mm-hmm.
I'm actually looking at the sort and the geograph thing, and I didn't really see any documentation of it. It seemed like one really preferable because they do like the same.
So you're talking about the one where I asked what's the difference between sorting and then grepping and then sorting? Okay, well, I'm not going to tell you the answer.
Or would you like look, because I looked at like the description of like the code and like it didn't really like say one way or the other.
Yeah.
If you do it on like a small sample, you will see a different result of what you're thinking of.
I got the same result.
The result. So the point of it is the result will be the same. The question is compare sort of grep some pattern and then pipe it to sort, or sort first and then pipe it to grep some pattern. So I'll give you a hint for this one. So hint, think about efficiency. Okay? That's your hint. Which one is more efficient? Or was that the actual question? That was basically the question?
Does Jira like work?
How does spread work? Like, does it go like to every line? Like,
Yeah. Maybe I can tell you some things that will help you answer this question. I mean, if all else fails, you could actually run some things and time them and see if one is better than the other. That would be.
Well, it's not enough to just say one's faster.
What's that?
Is it enough to just say faster because you don't know like the reason?
You got to know the reason. Yeah, because there's a reason.
Does grep like look line by line in some way and sorting it first to optimize that pattern somehow? Would it like grep the whole thing?
Okay. I don't know how to say this without completely giving away the answer. Okay, I'll give you a better hint. How much data is being sorted? All right, that's enough. That's all I'm doing. That's all I'm saying. All I'm saying. Other questions? Okay, you're using up your question. Thank you. Go ahead.
Like for the SBatch, do you just want us to explain like what we do to get the SBatch process to send it to like SBatch a shell file and have it go to the server and then come back? Or you just asking us to explain
Yeah, I'm just asking you to say that process in your own words.
like what we do basically? Because I know like it could be like more clear or detailed somehow we really want to do. We could like say what we do. So I don't know.
Yeah, I mean it's more from your perspective, less so the internals of how the queues work and all this sort of thing. That's not particularly important. Okay, so let's get started on some material here. Rubric. So this was our number one piece of feedback, and so I want to address it. So what I want from you in this class is the code that you turn in should be the best that you can write. You should be proud of it. You should think it's good, not beautiful, not ugly. The way you would want to give to a coworker or something like that. So some things about this matter. Some aspects really matter, and others are just cosmetic or a matter of taste and style. I'm interested in the things that I think really deeply matter for efficiency and conceptual understanding and good software engineering. The things with cosmetic things is like what naming convention you use, whether you use camel case or snake case. Are you familiar with these terms? No? Okay. More terms. Camel case, snake case. So that's when you have a var and it's called my var. So humps with the first part of the words, and snake case is just my underscore var. All right, so camel case got the humps and the strings and the letters. Snake case uses the underscores. These kinds of things, they don't matter. Right? I mean, they're just cosmetic. You can search and replace them. Just stick with whatever convention is going on. I tend to use snake case more often, but it doesn't matter. Okay. So as I mentioned, the graders will be referring to this lecture, to these lecture notes. And also what I'm trying to teach you here is stuff that applies generally, beyond Bash. Okay, so just general good software engineering practices. And I've talked a little bit about some of them, but I'll get more into what probably specifically you'll do for these types of homework assignments. Okay. I'm going to go to a little data set, winter 19 data. Okay, inside here I have my little transaction small, which is the same thing that we're analyzing, the same data set, but just a little bit, like 10 lines of it, so I can write some code on here. Okay, so the first point is to use variables. For example, if you do, well, let's see, head transaction small dot CSV. I'm going to put this in a some code. And you pipe this to cut -d, comma, -f, 5. Okay, so I copy and paste, I run this line. So what this cut command did, so the head command puts out the head of this data. I pipe it to the cut -d, comma, so the delimiter, it's common delimited file, and I -f5, I select out the 5th field. That's what this command means. So what does 5 mean here? Yeah, it means column 5. But when it's just sitting in the middle of my code like this, if you just hand someone a bunch of code and this -f5 is out in the middle like this, then this is called a magic number, okay, which is another term. Write that down, magic number. So it's a number that just appears in the middle of your code with no context. Five is a magic number. So how do we fix it? So therefore, this code is bad. Bad. Angry face. Sweet. So you might write that and start with it and kind of be developing it, and that's all fine and good. But let's fix it. So we use a variable. So we might say the actual variable that it's called is fiscal_year. So that seems like a pretty good choice for a name for a variable. So you write that as follows: fiscal year equals 5. And you access that variable as follows: fiscal year, just like that. Okay. So we run this little bit of program and we get exactly the same output. The difference is that this is now more readable. Right? We can look at this and have some idea of what's going on. Therefore, this gets a happy face. Okay. And there's another term in here that's environment variable. So this is a variable that Bash makes available that any programs can use after that. Fiscal year is the environment variable. 5 is the value. Okay. So you might also do something like think that fiscal year is a little too big. You don't want to write it. So you just go year. What do people think about this? Smiley face, frowny face. Huh? A mad face?
No, meh.
Meh? A meh face? Okay. I've reserved my meh face for a different one. But I think this is totally fine. So I'm giving it a happy face. I think it's totally fine if you want to do, because you might be using this year variable many times all over and you don't want to type out something really long. So that's fine.
For the variable, you write it in like all capitals, is it convention?
Yeah, that's just a convention in Bash. So if you do it like that, you'll be in good company because that's how almost most people do it, just a convention. But you could have lowercase and it would all work the same. Let's prove it. Try and run it. Copy paste. Yep, get the same output. So this is fine. Less conventional, but still fine. Happy face. All right. So, what if you did this? What if instead of saying year, you said column? So again, different command gives us exactly the same output, but this time we've substituted year with column. Happy face, smiley face, frowny face. Mad face? Mad face. Why mad face? What's wrong with this? It's unclear. Yeah, so there's no real improvement from what we originally had here. So this is just saying cut the fifth column here. Actually, I think it's worse than this because it adds one level of abstraction that's kind of unnecessary, unless you're using it all over the place. So looking at these two, it's adding complexity and not getting us anything in terms of being descriptive. So therefore it gets a sad face, frowny face, bad. Bad variable name, and that's the problem, bad variable name. Okay. So there's another way to be descriptive. You might write something like we originally had, dash F5, and then after this, you comment, you say, select the fiscal year column, something like this. So again, we're doing exactly the same thing, and we have documented our code by adding a column in here. Happy face, sad face. This is what I reserve my neutral face for. Neutral face. It's better than the first part. At least you have some idea of what is going on. But why would we prefer the good case over this? So let me compare the two. So this is, again, this is the one I liked best, or one of the ones I liked. So this one being good and this one being bad, why? Why is it better to put the meaning inside the variable names in the code rather than the comments? Yeah.
Can you change the variable assignment really easily?
Could change the variable, like you mean the name of the variable?
Using year in a bunch of different places, you want to shift the column.
Oh yeah, yeah. So it's more modular. So why is this way better? That was my question, and you could say so. You can change the value of year, and it will be propagated throughout the program. Program. Any other reasons?
It's on the top.
It's on the top.
Yes. I mean the variable is always on the top, so it's more.
Yeah, so I like this. So put global variables near the top. Yeah, I think that makes sense for global variables you're using all over the place. But if you were only using the variable in this one thing and you had 10 different statements beside this, then I think it would be okay to put the year right next to it in that case. I think that would be all right. So the advantage that this has for me is that you embed this meaning into the actual program itself through the variable names. So if, for whatever reason, you don't have your comments anymore, you don't lose anything by not having your comments. And having the comments inside there, it's a violation of the dry principle, the do not repeat yourself. So there you're actually repeating yourself in your comments, and it's actually pretty easy to do this. If you describe what something does, and then you change it so it does something else, then you have to change your comments so that it matches what it originally does. So I think there's some memes around this. It's like there's a like a box of cookies or something, and the label on it that says basmati rice, and it's like obviously not basmati rice, it's cookies. So this is what how comments can be a problem. I'll show you one more thing here. What if you had this? So, this does something different. Okay? We did year equals 6, head transaction, F the year. And we selected the wrong one, right? This is award ID. So is this better or worse? So you should be saying, Clark, oh, you might think, that's crazy, it's wrong. Of course it's bad, it's wrong. You did the wrong thing. You meant to select the year, but you didn't. But in my book, I think this is better. I think the clearer code is better. Even though it's wrong, your intention is totally clear. So the point I really want to make is that I value clarity over correctness. So this sort of thing, I mean, you'll still lose points. It's not right, but it is clear and it shows kind of a good programming practice. So when you're writing software, people get wrapped up in making everything correct and getting the right result at the end. So they write all this code and it becomes a big mess. But the guy who really taught me how to program was Raymond Hedinger, and he told me this essentially, that first, make your programs beautiful and clean and easy to read, and don't really worry about the bugs and stuff. The bugs will always be there. There are always going to be problems with it. But if you write it clear and nicely, then you can go back and fix those bugs. And you can maintain it, and other people can read it and see it. So that's where I stand on that. Okay, one more question. So the good solution uses this variable. What would be even better? So what could possibly be better than this? Well, that's the thing that's wrong. So the right thing would be better. So here we're hard coding. We're saying that the year is always the 5th column. Is there a better way to do this? The cut function? Say that one more time.
Taking the year as a variable or taking a variable that whichever columns you want to cut.
Yeah, so we would say the actual string that appears, and then look at the first row and see which position it appears in, right? Like the 5th or so. Yeah, so it would be better to infer it. That's what you're saying. So you can do this in Bash. You can somehow infer it. Problem is, it's a pain. And then at some point, because it's a big pain in the butt, you got to just give up and say, okay, that's good enough. So be pragmatic about it too. But if you think about what R and Python and anything that reads and deals with these data frames, that's what they all do. They read it and infer this stuff for you so you can refer to it by name and write good descriptive code with the column names to infer it. This is what R and Python do. So the 5, when it appears in the middle of the code, it was a magic number. Are there any numbers to where this rule doesn't apply? Magic number anti-pattern does not apply. Can you think of any?
Like, were you setting a iterator to 0?
Yeah, like when you set an iterator to 0. So 0 and 1 are really kind of special cases because they occur so frequently. You don't need to say 1 everywhere you're using 1 to select the first element, like the first of something. Yeah. So those numbers are 0 and 1. Maybe -1 also. But other than that, if you have these arbitrary numbers inside your code, it's not a good thing. Same with kind of arbitrary strings. That's something you want to avoid. So it's the same idea, magic string, magic number. Any questions on that? All right, let's move on to the next. The dry principle. What is this? Remind me. Do not repeat yourself. Repeat yourself. That's a motto worth repeating. Okay. Okay, and I won't make you watch me type all this stuff out. I'll just copy and paste it here. So, this is something that will come up inside your homework assignment. You probably are using the same data file, so you're using this in a whole bunch of different places. So we can contrast that with the way that does not use a variable. So instead of this, you have transaction small.csv. So here's the way you might write it initially. You're going through, you do one, you get that one done, you do the next one, you get that done, do the third, and so on. And by the time you keep doing this, you look back at your code and see that you've repeated this transaction small, this data file, a whole bunch of times. So that's why this one gets a frowny face. Frowny face. You don't want to be doing that. This way, you're repeating the name of the variable many times. And I think Evan said before, right, how if you wanted to point it at a different data file, for example, if you were trying it out just on some tiny version of the data, and then you want to scale it up to the large data set, what do you need to do? All you need to do is change the value of this data file in one place versus changing it in places throughout the script with some kind of global substitution. That is more error prone. So you want to do the way that's less error prone, which is like this. Okay. Well, I won't say what the lesson is. I'll let us figure it out. So let's do something similar to what we were doing before. Bash, go year equals 5. Cat my transaction small dot CSV, pipe it to sort dash dash key equals year. Oops, $year. Fields separator equals comma. Numeric sort. So here's one way to sort the data. So it sorts on an actual key, which means one of the columns inside the data. And Jared showed me this. I actually didn't know that sort would do this. So this is a handy thing I learned from office hours. Here's one way to write it. Here's another way. You can do the same thing. Sort dash K. Dash T comma dash N. So we get exactly the same result. So my question to you is, which is more clear? First, so if you had never seen bash before and someone showed you these two bits of code, then you could look at this and imagine what the sort is actually doing, because these are using the full parameter name. So you have the dash key, and you have the field separator, and numeric sort, okay? But with this, dash K, dash T comma, dash N, you have no idea what any of these things mean. So bash has this reputation of being kind of obtuse and cryptic, and this is why. This is exactly why. So you can even make people feel bad unintentionally by just being like, oh, you understand this, right? Oh, I mean, I probably do it to you unintentionally, and I don't mean to. But please call me out and ask what things mean. So write out parameter names was the lesson here. Write out parameter names. Question? Any? Yeah?
I have a question about like saving the data when you're working with it.
Uh-huh.
So when you unzip it, do you have to put it in a variable to use it?
So you can't put the data into a variable.
Or after you like add it to the screen, do you have to say that's a variable to use it?
Yeah, so
So you end up always like saving a local copy of it. Is there any way to like use it like a file pointer or something where you don't actually save it? Say like an
to make another copy
Yeah, because I checked it looked like it made another copy when I did mine.
of the whole data set, it should just be the selected things that I asked for each kind of question.
I just unzipped it and added it to the screen.
Oh, okay, so you unzip the whole thing first.
Yeah.
Okay, this was a really good question. The question was, what if I unzip the whole data first? And I think Suab maybe you asked me about this after class last time.
I don't think so.
No?
Didn't ring bell.
Rishi, did you? Someone asked me this. Okay. And they said that it seems like we're doing a lot of work because we keep unzipping the data with every single command we give it, right? It may seem like this to you, but it may actually be less work, and it may be faster to unzip it like this. And the reason conceptually why you can think of this as happening is you have right. you have something like a file system. And it is feeding you the raw bytes that are coming into the data, that are the actual data. So data is flowing out of here and into the unzip program. And then into whatever program that you want to write, like grep, say. So with this sort of thing, the fastest that your data can ever move through is only as fast as the slowest part of this pipeline. So the file system, there's a physical limit inside here. And I think it's around 200 megabytes per second. So you will never get faster than the file system can actually spit your data out. Yeah.
In this case, for this assignment on cluster, it's actually faster to use the raw file, because the individual CPU cores are so slow that unzipping becomes the bottleneck.
Oh, really?
Yeah.
Okay.
In any case, it's like a few percent off in each case, but it is.
Yeah, so, well, I don't know. I mean, I haven't actually checked with this data. So if you unzip it all and save the file?
Yeah, since unzipping is this slow part.
Unzipping is the slow part. Okay, so something will be the bottleneck. So in some of the stuff I've done with Hive and Hadoop, the disk file option, the disk itself, the physical disk is the bottleneck. So in this case, the unzip can be faster. So it's not necessarily slower by continuing to unzip every single time. But actually, yeah, it can also depend on what the file system is doing with the caching.
Yeah, if you
too.
do it on a desktop or laptop, it's faster to unzip it.
No, I think it depends on your system, your I/O.
So
Yeah.
for this case, it would be better to save the data from like a variable.
No, so you can't save these big data sets into variables. So you could save it on your local home directory, and then you'd have these 60 gigs in your home directory. That would be okay, but yeah, basically what I've asked you to do here is just unzip from the command line, and it doesn't take all that long for all of this. So yeah, did you have a question? No. Question? All right. So it may be faster, depending on the I/O of the system, essentially. I/O of the physical disk. It may be slower. Okay, I didn't give these happy faces. That one's happy. That one's sad. Now the lesson is use a consistent style in your programming. Type 2 cat. So this is the way that I've kind of like to work with pipelines. I'm starting with a cat and I'm ending with a cat, and I'm kind of building up my pipeline as I go. So when I want to add another step like that, I just add another line with another pipe at the end, and that lets me continue to add steps inside my program. So if I run this line, I can see what the actual results are and kind of check them to make sure that they are what I think they should be. When you want to add more steps inside here, you just write inside, you just add another line to this. So if I want to do grep, no file name, national, inside here, pipe, so it gives me more results. I can look at it and see if I see the word national somewhere. It's kind of hard in this small little space. But when you're building these commands for the homework assignment, they require, I think, at most 5 or 6 commands. So if you write in this fashion, you can keep adding these 5 or 6 commands in between the cats to see what it actually should be. So then maybe you add a sort with your key equals your year, field separator equals comma, dash dash, numeric sort. Oh, forgot my pipe at the end of there. My line's wrapped around. So this way you just keep on adding lines. And when you finally get it, when you figure out that you got the right result, then you can save it to something like result.txt at the very end by adding this redirect. Okay, so this right arrow redirect. So this is a way that works fine for me to develop. So over here you can see the commands that actually got entered. Here these right arrows are saying that it's waiting for more input because the parser sees the type at the end and then it goes on and expects more input, waits for you to get more input. And it saves all the results in your result.txt. So that's one way to do it. Alternatively, you might say, no, I am going to do it in a one-liner, by God, and it will be only one line. So you write something like this. Let me take off this numeric sort. Okay, so you write your whole thing in one-liner. Problem with this is it's pretty difficult to decipher. You have to read through and see where all the pipes are, and it can potentially grow very long, grow arbitrarily long. Versus this, your data processing pipeline, each step is a single line, so you have that going for you. And when you want to see what actual function or what processes are being called with tools, grep, sort, and cat, you just have to look at the first part of every one. So they get the same answer. If I take off that numeric sort. But that one is kind of ugly to read. With me? Tracking?
Yeah.
Questions? Okay. Angry face on that. Okay. So you might want to do something a little bit different, some variation of this. For example, maybe you don't like the spaces here, you find this more readable, something like this. Can anyone think of any reason that one of these would be better? So I've showed you that this one's kind of bad. It's all in one line. It's hard to read. But is this one better than this one to have the space here or not? What's that? Upper one? Do you find this more readable? Okay. I find it more readable, but I don't think there's really. I think this is a place where I would think the differences are more cosmetic. Okay, so people get really pedantic about style, like you have to write it with exactly these spaces here, exactly 2 or 4 spaces, and replace your tabs with spaces and all this. I don't care about that sort of thing. So I think either of these are fine. I just find the top one a little more readable. But I thought maybe someone would have some really cool reason that I didn't think of. So let's do. Okay. So let's do the submission scripts. SSH-A Clark FX Gauss.csc.ucf.edu. Okay, so this is something that if you're using a cluster more frequently, you can set up your SSH keys so I don't have to enter a password when I go inside here. So here is the example homework 4 directory that I showed you. I've been talking about do not repeat yourself. One way to repeat yourself is if you had this same submit script many times. So all these parameters inside the submit script should be mostly the same. So you could imagine writing one submit script for every single question, but that would be repeating yourself. One way to do it is by, so what this is doing is just running homework4.sh, where I've saved the results. So here we see the actual program that I've written. What this is doing is answering every single question, like say question 1, and then question 2, and it does it all inside the same script. This is fine, but it'll run sequentially. You're not getting the full benefit of the cluster when you do this, because each of these processing pipelines could run on their own. So this is totally fine if you have the time to wait for it. By the way, speaking of if you have the time to wait, if you have not been working on this assignment, please do not put off this assignment until the end, because it takes some time to run. Okay, so this is a valid way of doing it. But what if you want to get them all to run in parallel and you want them to use the same script? Do you remember the way to do that? Ampersand? Oh yeah, you could use the ampersand inside this. And you would have to change the number of tasks in your submission script to use many processors, right? To make them available to you. So there's another way that I talked about with the bash. So he said the ampersand, it's after, right? After the command?
And then you have to do wait so that run doesn't kill it too early.
You have to set a time limit?
No, so at the end of the script, you have to say wait so that it'll wait for all the background tasks to finish before.
Oh, okay. Oh, that's cool. I did not know that.
Otherwise, it'll just respond to commands and then it'll just die.
Huh, okay. Very cool. Okay, so I haven't covered the ampersand in class, but so what the ampersand will do is run a command in the background without putting the result to you and return your prompt to you immediately, even if it takes a long time. That's what the ampersand does. Okay, but there was a way that I showed you already. So the SBatch, there was 2 main modes. There's submit one thing, or there was the submit an array of jobs. So you can do it with the array job submission. So here's how you would do that. I made this array directory. So what I have here is one submission script and then scripts saying q1, q2.sh. I look at my submission script, and I'm running an array job through all my questions here. SBatch array, 1 through 2. Then when I actually go to run it, it's srun bash this. Q, whatever the number is, 1 through 5. So 1 through 5 will be substituted with this environmental variable slurm array task ID.sh. There's one nuance here. I'm using the same data file throughout. So rather than repeat my data file inside all of my q1.sh, so q1.sh looks just like this. I'm using the data file. What's going on in here is I say export data file equals this. So I added this export command to make this environmental variable available to all the processes that come out of this shell. That was kind of a mouthful. Any questions? Yeah?
Can you post this online?
Yeah, this is already posted.
Where is it? It's in the array. It's in the
Homework
Git
4.
home. When you call into the Git, there's like an array directory I can see.
An array directory? Yeah, I just made it before class. This is not there right now?
Oh, like you said, we have to like read.
You can just pull. After you've cloned it, you can just pull, and it'll take this out. So this makes the environment variable data file available to every process that runs under this script. Okay, so each of these will be ran as its own process, and they will be able to see that variable if you export it. And that's where they're using it. Any questions on this? Okay, we've got a little bit of time. I was kind of curious. srun -pty -p stack class --i. Okay, now I've got a terminal on a worker node. So suppose I define my data file equals scratch /transaction.zip, is that right? Check it, echo data file. I was curious, what's the difference if I do this unzip -p my data file, pipe it to head? So if I do this, I should just see the first few lines of my data file coming out to standard output, right? I think so. Okay, that's good. What if I pipe it to tail? What do you think? Will one be faster or slower? I don't know. No, I was really curious, so that's why I saved it, waited. So I pressed enter, so it is running, and nothing is flying by, which means we had almost exactly the same thing, but instead of piping to head, I'm piping to tail. So who can explain what is happening?
You have to go through every line to get to it.
Yeah. Yeah. So for a zip file, it's just getting sent the standard input. So we got this big stream of data being unzipped and flying through to my function, which is now tail. The tail is waiting until it sees the very last part of that to know what's the last part. As long as you're still giving more data to it, tail doesn't know that it's the end. But does it have to be like this? Will it be like this for a regular file? No? Okay, so this is the idea of seeking. on files. So you can seek to the very end or the very beginning of a file. If we knew where the end was, we could seek to the very end and go from there. So there might be some more clever way of doing the compression that lets you decompress from the back. But with unzip, you can only decompress from the front. So you need to uncompress one thing at a time in order. So you have to unzip the entire data until you get to the very end. And then it sends you the result. So this will apparently just run forever. Any questions on what we've done today? No? Okay. C-Tung, the TA, has office hours today at 2 in the conference room. But I'll see you Thursday. Oh, and take some more cookies if you want them, please.